The directions on this question were to factor it completely. We have to look at what the two terms have in common. Okay, they both have coefficients. Now, if it were like a 4 and a 3, we would say we can't pull anything out. In general, if we have a fraction, I do like for you to go ahead and factor out that fraction. So I am going to pull out the 1/4. We have a 3x minus 4 here and here, so we're going to take 1 out. And you take out the smaller exponent. So we have a 3 and a 2, so we would take out a square. They both have the x plus 2. So we take out the x plus 2 and we take out the smaller exponent. What's smaller, -4 or -3? -4, so we pull that out. Okay, now we see what we have left. So we had a 1/4 and I took it out, that's gone. I had 3x minus 4 to the third. I took out 3x minus 4 to the second, so there's 1 left. We had x plus 2 to the -4 and we took it out, so that's completely gone. The next term. We had a 3. We took out 1/4. When you take something out, it's dividing. So this is like 3 divided by 1/4. We know to divide fractions, you flip and multiply. So that's like 3 times 4 over 1, which is 12. We had a 3x minus 4 squared, and we took it out. We had x plus 2 to the -3, and we took out x plus 2 to the -4. When you factor that out, you subtract exponents. So -3 minus -4 is 1. So it's just an x plus 2 to the first. Are there questions to that point? I had several of you that did that and then you just stopped. So you stopped a little too soon. We can keep simplifying in here. So if you distribute your 12, and then we can combine like terms. Um, 3x and 12x is 15x. -4 and 24 is positive 20. And a lot of you stopped right here and I took off a half point. Why? Yeah. If you're looking at this parenthesis, both of those are divisible by 5. So if we pull out that 5, you just bring it to the front and multiply it with your 1/4. So that's 5/4. 3x minus 4 squared. X plus 2 to the -4. And we took out that 5, so that's 3x plus 4. What else do we need to talk about on here? Just set those in the corner of your desk. I'll come around and collect them later. And if you do have any other questions, you can ask me then. Let's go ahead and get out your notes so we can finish this last section. So yesterday we did all of the exponent part. Are you guys watching the video or joining class so you're staying caught up? You guys cause me a lot less stress than my other classes. You're doing what you're supposed to. I really appreciate it. Thank you very much. And we wrote down the properties of logs. That's where we left off. So I just want to do a few examples. I'm going to do some graphing and then using some of those properties. So if I ask you to graph f of x equals the natural log of x, Remember, natural log is like a log base e. F of x is the same as what variable? Y. So if you remember, when we graphed these last year, we just changed it to exponential form. Yesterday I said to go from to exponential, you start with the base, which is e here. So it's e to the y power equals x. If I made my t-chart, would it be easier to plug in for x or y? When we graph an exponential, what three things do we plug in? -1, 0, and 1. So I'm going to put those in for my y. E to the -1 is 1 over e. E to the 0 is 1. E to the first is e. All right. I'm guessing you probably don't know what 1 divided by e is approximately, so somebody plug that in. Give us a decimal approximation. There's an e button on the calculator. It's above the, well, there's one above the division and one above the natural log. You could use either one. So 1 divided by e is about 0.37. So my x there is a little less than a half. My y is -1. And we have 1, 0. E is like a 2.7. Will my x ever equal 0? When I take e to a power, can we ever get 0 out? No. Will we ever get a negative answer? No. So the exponentials we graphed yesterday had a horizontal asymptote. The log is actually just the inverse of an exponential, so it gets a vertical asymptote. So it looks like this. The y-axis there is acting as your vertical asymptote. The second one I asked you to graph was g of x equals log base, what was it? 2, 3, 3 of x. So if we change that to exponential, it would be 3, g of x is like a y equals x. 3 to the y equals x. Make our t-chart, plug in for y. 3 to the -1 is 1/3. 3 to the 0 is 1. 3 to the first is 3. So we have 1/3, -1, 1, 0, and 3, 1. These graphs look very similar. They always have that vertical asymptote. And then of course you could do transformations on these just like we did with the exponentials. You can move these left and right, up and down. If I'd asked you to graph like log base 3 of x minus 4, you would graph this as your parent function, and then what would your minus 4 do to your graph? Move it to the right 4. So where does your vertical asymptote end up there? Positive 4. You would have to, if you move left or right on these, the vertical asymptote moves with it. Okay, are we okay with the graphing piece? Let's use a properties. Sorry, I feel like these are kind of tiny. Can you guys read that? We have log base 2 of 80 minus log base 2 of 5. Okay, so you guys know we have our test, and I told you that on tests in here you can't use a calculator. That's part of MACC's policy. So you wouldn't just be able to put this in your calculator and get an answer. Now that does mean that I give you nice problems on the test. I'm not going to give you something ridiculous and expect you to work it out by hand. I will give you nice ones. But if I want to use properties of logs, if you have 2 logs being subtracted, how can you combine those into one? Division. So you write the log one time, and you divide the 80 over 5. So 80 divided by 5, if you didn't know that, you could work it out. So 80 divided by 5 is 16. So this is log base 2 of 16. You might be able to just look at this if you understand what a log is telling you. A log is like an exponent. When I say log base 2 of 16, I'm asking you 2 to what power equals 16? 4. So your answer is 4. You could also, if you needed to, set it equal to x and then rewrite it as an exponential. So 2 to the x power equals 16. It makes it a little more obvious what you're looking for here. 16 could be written as 2 to the 4th power, so you see again your x equals 4. So whichever path you take, if you can just tell me the 4, if not, write it out and solve it that way. Let's do some solving equations with this. Are there any questions so far? So the first one, ln of x equals 5. What we are going to do here is rewrite this in exponential form. So what's the base of an ln? E. So start with the base, go across the equal sign. So this means e to the 5th equals x. That's it. You don't have to tell me what e to the 5th is. Just leave it like that. That's our final answer. B. The natural log of x squared minus 1 equals 3. So the base of the natural log is e. So when I rewrite this, I get e to the 3rd equals x squared minus 1. Then what? Add your 1 I'm just going to leave e to the third as e to the third because we won't have a calculator on the test, so you're not going to turn this into some decimal. You're just going to leave it like that. How do you get rid of a square root? When you add a square root, what else do you need? So x is plus and minus the square root of e to the third plus 1. So we've solved a couple with logs, and our strategy is just to turn them into exponentials. Let's solve some that are already exponentials. Two to the x minus 5 equals 3. If we can, we get a common base. If it were like 2 to the x minus 5 equals 8. We would rewrite our 8 as 2 to the third. Can you do that with the 2 and 3? No. Do you guys remember what we did? We added logs into the problem. You can add any log you want. Last year we usually said use either the ln or the common log, just log base 10, because those are buttons on our calculator. In calculus, typically if we have exponentials or logs, they will be natural logs and e's, so I'll probably add a natural log, but it really doesn't matter. So I'm going to add my log to each side. Again, you could just add your regular log, and that's fine too. All right, now when I do this, what happens? Why is this beneficial?
Push your exponent out, right?
Yep, that exponent drops down. Okay, now we are just trying to solve for our x. Again, we're not putting anything in the calculator. We're not getting a decimal. So you can either distribute the log or divide it first. I'm just going to divide it. So x minus 5 equals the natural log of 3 over the natural log of 2. And then final step would be add your 5. So we get natural log of 3 over natural log of 2 with the plus 5 on the end. Questions there? Let's take a look at the last one. That says e to the 5 minus 3x equals 10. Okay, first step. What do we need? Add the log. If it's an e, I am definitely going to choose to add my ln. Okay, then exponent comes down. What is the natural log of E? 1. Natural log is log base E. It's like saying E to what power equals E. It's just a 1. So really that goes away. So you just have 5 minus 3x equals the natural log of 10. So subtract your 5, divide by negative 3. You could also, depending on the order you did things, you might have had it written like this. So either of those answers is fine. Any questions there? So that is the end of this section. You can now do everything on your handout. The rest of class is just time to work on the handout, the study guide, and ask me questions if you need it. If you finish your Chapter F handout and want to go ahead and check it and turn it in, that would be great. If you still have your Chapter E, if you wouldn't mind checking that and getting it to me before the end of class, I would appreciate it.